Hi, Assalamualaikum. For this video, we will go through Chapter 3, Subtopic 3.2, Conservation of Linear Momentum. For lecture, we will only focus on 3.2a, which is State Principle of Conservation of Linear Momentum. B and C will be delivered in tutorial. Okay, what is conservation of linear momentum? Last week we had learned about momentum, so we already know that momentum equals to mass times velocity. It can be initial velocity or it can be final velocity lah. But generally we write momentum P equals to m times v. So principle of conservation linear momentum state that the total momentum of an isolated system is constant. Total momentum. So as you can see here, we have two cars in orange and green. Both initially, for this case, has their own initial momentum before the collision. Okay. And after their collision, the momentum is still the same. Okay. So when the linear momentum state that total momentum of an isolated system is constant, that means total momentum before the collision, for this case, is equal to the total momentum after the collision. Alright, as you can see here, we have the formula, the general formula where we can write summation. This is a symbol of summation of momentum initial. So momentum from car green and momentum from orange car, we total up equals to the summation of momentum final, which is momentum after the collision. Alright, before I proceed with the 1 and 2 component of momentum, I would like to talk about what is an isolated system. It is important to mention conservation linear momentum only true or only correct when we consider the system is in an isolated system. Means since we have two cars here, green and orange, so we call this as a system. Okay, so what is isolated system? For isolated system, there's no external force. Okay, or we can write the external force is 0. Or we can also say that the F net is 0. Okay, what does it mean? What is the meaning of there's no external force? It can be the meaning of there's no external force does not mean that there's no force at all. It means that the external force are balanced. Okay. Later we will learn about force for next subtopic. When we say that the external force is 0, does not mean that there's no force at all act on these two cars. Okay, it means that even though we have the forces act on these two, but the force is or are balanced. Or we can also say the force when we add up all the forces act on these two cars become 0. That's what is meant by isolated system, which is net external force is 0 or no external force. Okay, I hope you take note lah this part. No external force means the force is balanced. Does not mean there's no force at all. Itu salah kalau cakap tak ada force. Salah. Okay, let's proceed with the next slide. Okay, in collision, we have one dimension collision on the left side, and another collision can be two dimension known as oblique. For our syllabus, we only have this one, the right side, two dimension. Okay, two dimension. Two dimension means in calculation we have to consider the x component and y component. So as you can see here, the red ball, also the red ball hit the green ball which is at rest. Okay, and after this one hit the green ball, they move separately after the collision. So as you can see here, the red ball has a finite angle and the green ball also has a finite angle. If we separate these two, we have the x component and y component. Okay, it doesn't matter if your before collision is only on x component, but you need to see the whole picture, which is before and after collision. Where after the collision we have the angle, isn't it? So we have to consider this as two-dimension case. Okay, uh, not necessarily initial must have angle, final must have angle. Then at that time you consider this as 2D. No need. It is either before collision or after collision has this angle. That means we have to treat this situation as two dimension. So since it is two dimension and we know that momentum is a vector quantity, therefore we have to write the conservation of linear momentum, one for x component. See my laser pen showing you the x component, and another one is y component. Okay, for calculation, you have to write down this one, and for u and v you have to include the x component, and for u and v, for y component you also need to include the y component. So the detail about how to calculate this thing will be delivered in tutorial. Okay, let's have a look on these two questions. The first question, the total momentum before a collision is answer is A, equal to the total momentum after a collision. It is conservation of linear momentum. Okay, second question, according to the law of conservation momentum, when two objects collide, A, both objects lose momentum. Wrong. If lose, then the total will be reduced. Wrong, because conservation of linear momentum, the total momentum before and after is equal. Momentum is always loss or gain. Okay, both objects gain momentum. Momentum is neither loss nor gain. The perfect one is D lah. Okay, right, that's all.